All right, so this is review for lessons 10.4 through 10.6. So 10.4 and 10.6, or 10.4 and 10.5 are at the origin, and 10.6 is vertex, or the center is not at the origin anymore. Okay, so just remember for ellipse, it's always about whichever one's bigger, and then the foci has two equations depending on if A is bigger than B or B bigger than A. All right, so let's start, and we need to graph this. So first, the center's at the origin. Shh, I'm recording. Shh, just like whisper. It's okay. I don't mind you whispering. Thank you. All right, so we're gonna go a distance of 2 in each direction and 4 up and down. Okay, so there's our ellipse. So 2 in each direction. And the vertices are always the ones that are the farther ones away from the center. So in this case, our vertices are at 0 plus or minus 4. Co-vertices are going to be the shorter distance away. In this case, they would be at plus or minus 2, 0. And the foci. Anytime you have the foci, you have to use the foci equation. And it's c squared equals big number minus small number. So c squared equals 12. Which would mean that c equals plus and minus 2 rad 3. So from the center, we would need to go up and down because the foci are always on the major axis. So that would be at 0 plus or minus 2 rad 3. All right, I think we did that one in class. Number 2 we didn't do in class, so let's look at number 2. In this case, the vertices are out at 6 and negative 6 on the x-axis. And yeah, my graph didn't quite make it here, so 6, negative 6. And then 5 and negative 5. So we draw our ellipse. It almost looks circular because 5 and 6 are very close to one another, but it's an ellipse off the charts. 1, 2, 3, 4, 5, yeah, 6. Okay, so your vertices are out here and here at plus or minus 6, 0. And co-vertices are here and here at 0 plus or minus 5. That has to do with the fact that this is a shorter distance. It's a distance of 5, and the other way is a distance of 6. So the vertices are always the farther away. All right, let's take a look at the foci. Foci would be c squared equals 36 minus 25. It's always the big number minus the small number. So c would equal plus or minus 36 minus 25 is 11, square root of 11. Okay, that means from the center, I would go on the longer axis, a distance of plus and minus square root 11. And those will be your foci. All right, so now those were given the equations, find all the stuff. Now here's some stuff and find the equations. So for this one, we're given one of the co-vertices, a co-vertex, is at 0, negative 5. So that would be right here. Negative 5. And a vertex is given to us as 7, 0. So you're way out here at 7, 0. Okay. All right, so then draw ellipse goes around like that. And we have everything we need. We have x squared over something plus y squared over something equals 1. And the distance here to there is 7. And from here to here, the distance is 5. So we're going to go ahead and write 7 squared is 49. So that's left and right, goes underneath the x. And then up and down would go underneath the y, and that would be 25. That's a pretty easy one compared to some of the harder ones that we do on these. Okay, this time it has the foci. Whenever we have the foci, it gets a little bit harder. So let's go ahead and graph the foci at 5 and negative 5. Foci. And then the co-vertices are at 1 and negative 1 up and down. So this would be an ellipse that goes around like that. And so the ellipse equation is always x squared plus y squared equals 1, and we fill in the blanks underneath. Now I only have one of them this time. I have the up and down length from the center is 1. So I square that number and I put it under y because it's going up and down. Now, this is not A. A is all the way out to here. This is actually C. So we're going to do C is a length of 5. So C squared equals the longer axis, which is A squared, minus the shorter one, which is 1. And then add 1 to the other side, and A squared is 26. Let me write that there. Okay, and that's the equation for that one. Yeah, Algebra 2. All right, so we're ready to go to the next page.
Okay, so this is Algebra 2, is my understanding. Don't take ham because you'll fail it and get a
No,
49
ham is good.
on the final second semester. So
All right, thank you for your input, guest speaker. Okay, that was Sophia. All right, so 10-5, we're going to do hyperbolas. Hyperbolas are all about which one comes first. It's not about which one's bigger, which one's smaller. Okay. All right, so these would be side to side, and that would be up and down. Don't forget the foci equation. There's only one. And we also need asymptote equations. All right, so here we go. Vertices. So these are still centered at the origin. And our vertices would be left and right a distance of 1 because x is first. Then we would go up and down a distance of 2. And we would draw, let me zoom in a little bit. We would draw that rectangle, go through the origin, out the sides. There we go. And then this would be here, going through that point. I tend to miss it sometimes. And then here and there. Okay, so that's our hyperbola. So let's talk about our vertices. The vertices are right here and here at plus and minus 1, 0. These are not vertices, there and there, so don't even write them down. All right, asymptotes. The asymptotes are these lines that are in red. And the way that you find the asymptotes is you do y equals plus or minus rise over run. So if you look at this, you rise 2 from the center and you run 1. So the slope is 2 over 1, and then don't forget the x. So our asymptote equations, there's 2 of them. Y equals plus or minus 2x. All right, the foci. Foci, c squared equals a squared plus b squared. So c would equal plus or minus rad 5. So from the center, we're going to go out rad 5. Now, why not up and down? Because this is a side-to-side hyperbola. So our foci have to be in here somewhere. So our foci then would be at plus or minus rad 5, 0. All right, number 6. First thing you need to do on number 6 is you have to write this equation in standard form. So we're going to take everything here and divide everybody by 225. So that our equation for our ellipse equals 1. That's our standard form equation, equals 1. So make sure you reduce your fraction. 225. It's probably 9, isn't it? It is. Okay, so it's y squared over 9 minus x squared over 25 equals 1. So that would be our standard form equation for our hyperbola. Now, note, y is first. So you're going to go up and down a distance of 3. And then side to side a distance of 5. And it doesn't matter that 5 is bigger than 3. All it matters is that y was first. So you draw your rectangle. And you draw the asymptotes. There we go. And then you finally can draw your graph. Goes through that point and right along the asymptotes there. Okay? It didn't ask you for all the parts, but let's do them really quickly. So our vertices for this problem would be this point and that point. So that would be 0 plus or minus 3. The asymptotes are y equals plus or minus. Here you rise 3 and you run 5. So 3/5 x. And then the foci are c squared equals 25 plus 9. So then 25 plus 9 is 34. So c equals plus or minus rad 34. Now, foci, remember, have to be listed as a point with an x and a y coordinate. In this case, our foci are up and down from the center because our hyperbola goes up and down. So the foci would be at 0 plus or minus rad 34, and there's no perfect squares in 34. All right, 2 more for this lesson. Here we go. So this one, let's see, write the equation of the hyperbola. Center still at the origin, and here's the information given. So we're going to go foci, left and right, 5 and negative 5. We know we're going to use the foci equation. Vertices, 3 and negative 3. So this would open side to side because your foci are always inside of the hyperbola. Okay, now knowing that it opens side to side, we're going to have x squared minus y squared equals 1. So one of them we have. The center out to our vertices is a distance of 3. So we're going to square that, and we're going to put it there underneath the x because it's going side to side. Now, we have the foci, so we have to use the foci equation. Foci equation is c squared equals a squared plus b squared. So the hyperbola has a minus in the middle, its foci will have a positive. So the distance that the foci is 5. So 5 squared equals a squared plus b squared. So subtract 9 to the other side, and then you get that b squared is 16. So finally go to your equation and put that number right underneath the y squared. All right, and finally number 8. This one, you'll want to, plot the foci, 0, 8, and 0, negative 8, and then the vertices, which are at 3 and negative 3. And this one opens up and down this time. So it's going to be y squared minus x squared equals 1. All right, once again, I think the last one, the vertices were 3. Oh yeah, they were. So this is 3, but this time I'm going to put this underneath the y, 3 squared. And then we get 64. Ooh, I usually do that in green. Hold on. Yes. All right, so 64 b squared equals a squared, c squared equals a squared plus b squared. So 64 minus 9 is 55. So go up to your equation and write 55. Perfect. Okay, so that was 10-5. 10-6. 10-6. Now, we're not at the origin anymore. We've been shifted off to a center, and our center for these is going to be at HK. Okay, so let's look at number 9. Write an equation for a hyperbola, foci at, and let's go ahead and graph this. 1, 2, 3, 1, 2, 3, 4, and negative 4. There you go. There's your foci. Okay, it's a hyperbola. Foci are here. And it also tells us that we have a transverse axis of 2 units. Okay, here's what I want you to do. I want you to find the center. And the center is exactly in the middle of the foci. In this case, the center is at 3, 0. And the transverse axis would be a length of 4, which means you would go up and down a distance of 2. And that's what your graph would look like. So here we go. We're going to write the equation. It's going to be y first, and here's h, and here's k. So y minus 0 squared, which is just y squared, minus, because it's a hyperbola, minus x minus 3 squared equals 1. Okay, so one of them we have that this right here is 2, and so 2 squared is 4. Now the other thing that we have is foci. Whenever we have the foci, we're going to use the foci equation. The foci is a distance of 4 from the center. So c squared equals a squared plus b squared. So a squared would equal 12. Go up here, plug in 12. Done. The only really thing that's different is just the center, and you have to just count from there. All right, number 10. Ooh, 22. Gross. Oh, focus is at 6, 3. Sorry, 2 typos. Wow. All right, so here we go. I'll go kind of long on this one. So we're at 2, 3 for one of my vertices, and 22, 3. 22. This is kind of a jerk move. There we go. And so those are my vertices. So this is going to open that way. And then a focus is at 1, 2, 3, 4, 5. Oh, it's an ellipse. Oh, whoopsies. You know, I didn't read it, and then I realized it was an ellipse when one of my focus points was on the inside. 1, 2, 3, 4, 5, 6, 3. Okay. So who knows, it's going to go something like that. Well, let's first start by finding the center of this thing. Well, if I'm starting at 2 and I'm going to 22, all right? All right, then the distance is 20, which means half of that is 10. So I'm going to count from 2. I'm going to go a distance to 10, 10 more than 2. So that would be out here at 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's the center. So that center is at 12, 3. Okay. And so this is a distance of 10 here, and then that whole thing is 10. Now the other distance that I'm interested in is this distance to the foci from the center. We're going to need that. So if I'm at 6 and this is 10, then that would be a distance of 4. All right, we are ready. Here we go. This is an ellipse, so we're going to do x minus 12 squared plus y minus 3 squared equals 1. So left and right, I went from the center a distance of 10, so that would be 100. And then I have foci, so I have to use my foci equation. Foci equation is c squared equals big number minus small number. So subtract 100 to the other side, and you get negative 84 equals negative b squared. So b squared is 84. Go up here to where b squared is, plug 84 in, and you are done. That was a tough one because it was a lot like big numbers. All right, number 11. Okay, first find the center. It's a very important point. That's why you find it first. We have 3, negative 2. So 1, 2, 3, negative 2. Everything's going to come off of that. So this is an ellipse. It didn't tell you what it was, but you can tell because of the plus in the middle. So you're going to go 2 in each direction, left and right. And then we're going to go up and down. 1, 2, 3. And 1, 2, 3. Okay. And then we can draw our ellipse. Don't forget to actually draw it after you plot the points. Now the vertices are the ones that are farther away. So let's go ahead and talk about where these vertices are. This one vertex is at 3, positive 1. This vertex is at 3, negative 5. So just look at them on your graph and then give me the points that they are at. All right, the blue ones are the co-vertices. This blue one is at the point 1, negative 2. And this one over here is at 5, negative 2. Okay, and now for the foci. C squared equals big number minus small number. C squared equals plus or minus, C equals plus or minus rad 5. Now, what that means is that's going to go up and down from the center, rad 5. So here's my center, and the center is right here, this point. And so the foci are going to go up and down, which only affects the y value. So my foci would be at 3, and then from -2, I would go up and down a distance of rad 5. Whew. All right, so number 12. This one is a hyperbola because it has a minus. Start with the center, and it's not only just a hyperbola, it's a hyperbola because x is first that goes left and right, like that. The center is 1, 3. So we go to 1, 1, 2, 3. And from here, I'm going to go out a distance of 4. So let's do that. 1, 2, 3, 4. That's one of my vertices. And 1, 2, 3, 4. That's the other one. Then I'm going to go up and down a distance of 2. So 1, 2, and 1, 2. So then I'm going to draw this rectangle in here. And the asymptotes through. Oops, they should go through the center. A little messy. Okay. And then this would be the graph here and here. There we go. Don't touch the asymptotes. Go right alongside of them. All right, so the vertices are these points right here and here. It's not about which one's first. Remember, it's about which one's bigger. It's about which one's first. So from the center, we went 4 and 4. So what are those points? Well, that's the point 1, 2, 3, 4, 5, 1, 2, 3. So it's the point 5, 3. And this one is the point 1, 2, -3, and then 1, 2, 3. So just count it on your graph. You can see it. And then the foci. C squared equals the numbers plus each other. Whoa, sorry about that. So C squared equals 20, which means C equals plus or minus rad 20. Make sure you rationalize and get 2 rad 5. All right, now your answer is not 2 rad 5. So many times people will be like, okay, that's my answer. The answer has to be a point. From the center, the point's moving that way and that way. So let's talk about this. Remember, the center is 1, 3. And I need to go to the left and to the right a distance of 2 rad 5. That is only going to affect the x value. So my foci would be 1 plus or minus 2 rad 5, comma 3. All right, we are almost done. Identify each of the following. Okay, so take a look. All we have to do is all we need to do is look at these squared terms. Squared terms. And I think we did this in class, yeah. So here the square terms have a minus in the middle. It's a hyperbola. This one right here, over here, has 2 squared terms. That's a plus in the middle, and the numbers in front of them are different. It's an ellipse. Here, 1 y squared term, it's a parabola, and this one has 2 that are exactly the same with a plus in the middle, circle. All right, there is a review tomorrow morning at 7:40. Come rain or shine. See you then.